In this example, we're asked to use Microsoft Excel to calculate the following binomial probability. In this binomial probability experiment, we conduct 20 trials and the outcome of success for each trial is 0.25. We're going to find the following results and round our answers to 4 decimal places. So the first one is the probability that there are exactly 5 successes. The second, that the probability is less than 5 successes, and then the other one, the probability that there are at least 5 successes. So we have a formula in Microsoft Excel to help us do this. It's called binom.dist. It is the binomial distribution, and it tells us how to find a probability based on the binomial probability experiment. And remember that a binomial probability experiment is one in which we have 2 possible outcomes, either success, however we define that, or failure. Flipping a coin to get heads, for example, is a binomial experiment with a probability of 1/2. So let's see what we want to do right here. Let's go to Excel, share our screen. Here's the problem, just as stated in the screen. How should we do it? Well, let's apply the first one. It says we want to find the probability that there are exactly 5 successes. So what I'm going to do is I'm going to type in my formula, putting in the relevant information. That is, we start by typing B-I-N-O, and we see that the formula can come up. You can just go ahead and click that, and it's going to ask you for the number of S. Number of S is the number of successes, so we're going to enter 5 right here because we have exactly 5 responses. How many trials? In the description we're told there were 20 trials, and the probability of success for each trial was 0.25. Finally, it says cumulative. What does that mean? Well, we're either going to choose true for the cumulative probability distribution or false for the probability mass function. In this case, we want to get exactly 5, so we're going to hit false because we don't want to accumulate our probabilities. We just want the probability at exactly 5. So this is how we're going to enter it in this case, and our probability gives us 0.20233, which we would round to our answer of 0.2023. Okay. How about the next one, the probability that there are less than 5 successes? Well, be very careful with the way you interpret this. To have less than 5 successes, this means that there are going to be there are 0 successes, 1, 2, 3, or 4 successes. And just like in our distribution table, all of our probabilities are additive. So we're going to take the probabilities and add them up. Well, rather than doing the probability like we did above individually for x equals 0, 1, 2, 3, and 4, we're going to do it this way. We're going to put in our binomial distribution probability function right here. We say that we're going to go up to as many as 4 successes because we want less than 5 in this case. The number of trials again is 20, and the probability of getting success in any one trial is 0.25. This time we're going to choose true because we do want the cumulative distribution function. That is, it's going to add up all of the probabilities from 0 to whatever number x you enter in this function, and in this case that's 4. Typing in that formula, we see we get x. So our answer that we are going to type in for this one would be 0.4148. There we go. So what about the other one, the probability that there are at least 5 successes? Well, if there are at least 5 successes, that means there are 5, or 6, or 7, or 8, or 9, or 10, or forever. We can't add all of those up, can we? No, because in Excel, all this formula does, like we did it above, is to give you the probabilities for everything up to. That means for all the probabilities less than a number, or less than or equal to a number. But we'll note that the probability here is going to be the exact opposite of what we were told before. That is, if we have a probability that there are less than 5 successes, all of the possible probabilities must add up to 100%. Therefore, what we're going to do is we're going to find, by using a formula saying the probability that x is greater than or equal to 5 will be equal to 1 minus the probability that x is less than 5. Get it? We're just going to take whatever we got above and subtract it from 1. So we can just simply say 1 minus this guy right here. And there's our answer right now. We're going to say, if we round that to 4 decimal places, 0.5852. 852. There we go. Good luck.